So, chapter 4, we start out by talking about this word right here. For some reason, people get confused when we say this word. What are the factors of a number? Perfect. The numbers multiplied together to get to your original number. Okay? So when we talk about factors, there's really two groups of these numbers, right? We could split the numbers into prime numbers and composite numbers. Ever heard of that? What does it mean if it's a number is a prime number? And what are those two numbers? Exactly right. Perfect. So prime numbers is when it only has two factors. And those two factors are 1 and the number. And then, so composite numbers obviously have, more than 2. Now they might only have 4, but that's okay. Now when you're asked to list your factors, how do you know when you have them all? Or how would you go about finding the factors of a number? If they're the numbers that are multiplied together, how could I find a factor of any number? Divide, right? And so I would start going through and dividing by every single number. And if it comes out as a whole number, where it doesn't have a decimal, that means that it is a factor, right? And so then that number has to be multiplied to something else to get back to that original number. But how do I know when I'm done? How do I know when I have them all? If I'm starting at the bottom, say at 1, because everything has to use 1, and then I go to 2, and then I go to 3, and so on and so forth. How do I know when to stop? When you get to the, okay, if I went all the way to the original number. But do I have to necessarily go? What happens if my number is 947? Right? I don't want to go all the way to 947, do I? That'd take me forever. So how do I know when I'm there? How do I know when I've tried all the numbers?
You could do numbers that end in 0, numbers that end in 2.
Okay. And we're going to talk about that. But how do you know that you've tried all those? And I didn't miss one, that there's one of those that doesn't really have a rule. Maybe I'm saying it in a way that you don't quite understand. If I asked you to tell me what the factors of 72 are, what would you tell me? 1 times 72. Okay, what else?
2 36.
Okay, keep going.
4 times
8 times what? Okay. Somebody said 4 times something.
4 times 18.
4 times 18. Is that right?
Yeah.
Anybody? Okay. Any more? Does 3 work?
3 divided by 26. 6 and 12.
6 and 12? Wait. 3 and what?
36.
Already got 36. Somebody take 72 divided by 3.
24.
24. That sounds better. What do we have for 6?
12.
Okay? So, what Addison said is, I got to go all the way to 72. Right? But look how close these two numbers are. If I would 8 times 9, what's my next number after 8? 9, right? And if I did 9, it would be 9 times what? Are those two different sets of factors? No. So how do I know when I'm done? Or look, see how these two are really close together? Basically, I know that I'm done when the numbers are exactly the same. That makes sense? So like for 36, if I had 6 times 6, those would be factors. When I have the same number times itself, I know I don't have to try 7. That makes sense? Okay? So, we could go through all of these, all the numbers like this, right? And I could use a calculator and divide if I had a calculator. Okay? But they try to make it a little easier by having rules, right? And so we're going to talk about some divisibility rules. That's how you spell it. So, do I have to use these rules? Heck no, but sometimes you might think about these rules, and it just makes it a little easier. Divisibility rules occur with these numbers: 2, 3, 5, 6, and 10. So on your assignment, maybe even on the first quiz, they might say, what are the factors using the divisibility rules? And then you would go through these. So, how do I know if a number is divisible by 2?
If it's even.
Yeah, if the number, is even. But I should be more specific than that even, right? What number has to be even? The last number, okay? Or the number in the what? Yeah, in the 1 spot, right? Everybody understand what I'm saying, in the 1 spot? Well, we should actually say that because like 72, right? 7 is not an even number, but it's still 72 would have been divisible by 2, okay? How about divisible by 3? Any idea what the rule is? If a number is divisible by 3, you take the sum of all the digits. What do I mean by digits? Just the numbers in the number. Okay? So, for instance, 72, I would take the sum, which means what? Add the digits together and we get what?
9.
If 9 is divisible by 3, then 72 is divisible by 3. Make sense? Bless you. Everybody okay with that? Okay? 5. We should know this one. Bless you again.
Ends in a 0 or 5.
Yeah. So if the number in the 1 spot again is a 5, 4, 0. How about 6? Any idea for 6? 6 is probably the most special one. 6, it's divisible by 6. I'm going to show you some weird thing here. Anybody ever seen IFF? This right here means if and only if. Okay? So if and only if the number is, what are we going to guess?
Divide it. You can it has 2 and 3 as a factor.
Okay, perfect. Is divisible
That's the word. I couldn't think of the word.
by 2 and 3. It has to be both of them. And then last but not least, 10 would be what? Yep. The number in the 1 spot is a 0. So again, these are just kind of rules that you would have to or remember, but especially 2, 5, and 10, those are pretty easy, and we would really remember those way back from when, right? Since we were really little. Not that we're really big right now, but since we're really little. Now, if they ask us to find just these factors, that's fine. But if they ask you to find all the factors, then you got to go through even all the odd numbers, right? So like 7, and test all those too. And the only way some of those can be done is by doing division. Okay? But remember then, every single number will always have 1 as a factor. Okay? So, let's try this out. Example, 36. What are the factors of 36? So again, if you want to use the divisibility rules, you can. If you just can go through them faster without the divisibility rules, just go through them. But we want all of them. Okay? And don't forget 1 and itself. And then we're going to try some more. So if you're done with 36 already, you can go to 435. That's a big one. And you can go to 3050. Try those two if you get done with the first one. Yes, sir.
Is there a way you want us to write like the order?
No. So you can either do it like this. That would show me all the factors. Or you can just list the numbers individually. That's fine too. Good question. So if you get 36 done, then go to those two also. So these might be some where you might have to actually get a calculator, right? Because otherwise you gotta start doing a lot of division, don't you? If I looked at my divisibility rules for these ones right here, does 2 work for 435? No. Does 3?
Yes.
Yeah, because they added up. 5, because it ends in a 5. 6, no, because it wasn't 2. And then how about 10? No. Anybody find more of them on this one? After 10? Bueller. Just gotta write the right number. Maybe not. So again, this would be one of the things that I'm talking about, how I know that I would be done. So if I did 435 divided by 14, it's 14 and 31 point something. Well, obviously it's not a factor because it's not an even number, but they're getting closer and closer together, right? 14 and 31 are closer and closer together. So after I would get where the numbers passed the same number, then I could stop. Did anybody find any more for this one? No? Okay. Did I get all of them for 36? And what'd you do for this big dog? Obviously the first one.
I got 7 and 50.
7 and 50? I don't think so.
Maybe 7 to 500.
50 times 7 would be 350, right? So let's just go with the divisibility rules. Would it be divisible by 2?
Yes.
Yeah, 2 times what?
100. No, 1,525.
1525, okay? How about 3? Did 3 work? 3 plus 5 is only 8. 8 can't be divisible by 3. Does 5 work?
Yeah.
Heck yes. 5 times what? How many times does 5 go into 30? 6. How many into 5? 1, 0. So you should have got 610. Does 6 work? No, because 3 didn't work. And then what about 10? 10 should work, right? 10 times what? 305. And then there could be more, but that would really be a pain in the you know what, right? So with numbers like this, they probably will just ask about the divisibility rules. If they ask you for all the factors, then you'd have to go through all the way until you got. So notice how far away my numbers are here. 10 and 305. I got a lot of other options I can go through, right? So this one would take a long time, and you'd probably want to use a calculator. Okay? Not that we really like the calculator, but otherwise it's going to take you forever to do the math. Okay? Questions with this? So again, if they ask you by the divisibility rules, we just use those 5 numbers. If they ask you for all the factors, then you got to do all of them until you find all of them. But again, they won't give you numbers like that where it's really hard.
Would 50 and 61 work?
50 and 61.
Yeah.
Oops, I want to go this way. 0, 5. There you go. 50 and 61. So again, notice how close they're getting together, right? So again, once I get up to 59, then I can stop. So we found another one. All right. Questions here? So the next thing that they introduce here is something called a monomial. Ever heard of this word? Nope. Awesome. You're going to actually learn something today. So what would you tell me if I told you that another word for monomial is the word term? Now, could you tell me what it is? We've talked about terms, right? We talked about terms last chapter when we were talking about adding and subtracting or combining like terms, right? So what was a term? Or what's a monomial? What's a term? Well, that can inspire me.
A number, variable, or product.
A number, a variable, or a product. What do I mean by a product again?
Like an answer to a multiplication.
Yeah, so these are things multiplied together. We want to say things because it could be a number, it could be a variable, right? How do I show that a number and a variable are multiplied together?
Put them right next to each other.
We put them right next to each other, okay? So, big star here. Monomials cannot have a plus or a minus in between two numbers or variables. So So again, it's a product, it's not addition and subtraction. So, my examples of this, obviously, if I had a number, it's any number, 237. That's one term, because it's one number. A variable, it's any variable. It could include exponents. So k to the fourth is one monomial, or a monomial, or one term. And then it could be a product, which means that it could be a number, 22kz to the fourth. But notice, all of them are multiplied together. Okay? Make sense? So then, we talk about things that are not monomials. So what's an example of a not? Well, this is when I have two terms, but they're split up between a positive or a minus, a plus or a minus. So here, this is a special monomial because it goes on and has two terms in it, and you'll learn about this more, I think, probably at the end of the year. Okay? But this would be called a binomial for future reference. Bi meaning what? Two, right? A bicycle has two things. So it could have a plus in between. It could have a minus in between. So 3k minus 18f. So anything that has a negative sign or a minus sign in between terms is not a monomial. What do you think about this one? If I gave you 4 and then parentheses, a plus t inside parentheses, would you say that this is or isn't a monomial? It's a product, isn't it?
It's separated between.
Yeah, so if I would do what to this? How do I get that 4 through that parentheses?
Distribute.
I distribute it, right? Which means what?
Multiply.
Multiplication. If I multiplied this, I would get what?
4a plus 14.
And now, doesn't it look like this one over here? So is this a monomial? Like no, right? Because when I distribute it, it doesn't work. And then the last one is this right here. A fraction. But this is the important part. The fractions only if the variable is in the denominator. Okay? So I think we talked about this this next example before, but I'm going to show it to you again. So do you understand what we're seeing here between the two kinds? Between the ones that are and the ones that aren't? Everybody okay with that? Okay, so the ones that I want to show you now is this. So I'm asking you, is this or is this not a monomial? How about 7p times q? So what do you think? If I could, or if this is my problem on my assignment, would you say this is or is not a monomial? It is, because the first thing that I should always do in a problem is what? What did we tell you to always try to do?
Take out like parentheses.
Gracie?
Simplify.
Always simplify. Yeah, take out the parentheses is a good one, but always simplify. So simplifying means do it if I can do the problem. So we would merge this into 7pq, right? And now this is like this over here, right? It's just a product. They're all multiplied together. Okay? So again, always simplify. This means, what else would we do? So you might multiply. As Alex said, you might distribute. which again is multiplying, but this would be getting rid of your parentheses. What else are ways of simplifying? What else could you do to a problem to make it smaller besides multiplying or distributing? We could also combine like terms. Remember when we're looking at for cows and adding them to more cows? Okay, so that's just another one. So, a couple bit more. This is what you're going to have to do on your assignment. Is this right here a monomial or not?
No.
No, because
Separated.
the plus sign, right? Next one. Yes or no?
Yes.
No.
No, because the first thing I should do is simplify, and we would get what?
4n.
4n plus 4.
Okay? Now, we definitely see that it's just like the one that we had above it, right? What about this one?
Yes.
Oh.
Because the variable's on top, right? Why can I say yes to this, besides the variable's on top?
There's nothing, there's no adding or subtracting.
Okay, there's no adding and subtracting. So what's the difference between this division here, though, and this division here, besides the variable being on top, is that I could rewrite this problem right here, and this is the part that I think we've talked about before, which it was probably quite a while ago. What is the coefficient in front of x?
1.
Everybody agree?
Yeah.
So does everybody see that there's a 1/3 there?
Yeah.
Everybody agree? So could I realistically rewrite this as 1/3 times x? And now would you see this as a multiplication problem or a product? And that's why this still works. Does that make sense? So if the variable's on the top, you can say yes, it is a monomial. If the variable's on the bottom, you say no. Okay? How about this one? Because what? It's just all multiplication, right? How about yes? What if I do this?
Yes. It just makes it negative.
It just makes it negative, right? Because really, again, what is this saying? It's saying it's negative 38, or I could rewrite this as negative 1 times 38. Does that help now? If it's a product and I simplify it, I get those same thing, right? So it's this. Anytime that I have a number, it doesn't matter if it's a positive or negative, then it works. The only time it doesn't work is if that positive or negative is with a variable being added or subtracted. Make sense? Okay. That's it. Questions for that stuff?
Doesn't Ethan's hair look like he got a bowl cut?
He does.
It looks like he got a bowl cut.
What's wrong with that?
He's weird. He looks weird.
What's